So we have a half log 625 plus a third log 125 over 2 minus half log 16. I say that this one will be equal to, according to the third law of logarithm, it is log 625 power half. Log 625 power half. And the log 625 power half is the square root of 625. Then plus log 1, a third log 125 is log 125 power a third, and that is log cube root of 125. And then I divide by 2 is the same as log 100. And then this one is log square root of 16. So this comes to, this will be log 5, no, log 25 plus log 5 over log 100 minus log 4. So log 25 plus log 5 is the same as multiplying 25 by 5, and then log 100 minus 4 is like taking 100 over 4, and this is log 125 over log 25. Log 125 over log 25. And this gives me log 5 cubed over log 5 squared, and that will be 3 log 5 over 2 log 5. Then this is 3 over 2, which is 1.5. So remember, you should not give your answers in proper fraction. Don't leave your answers improper. Give your answers either 1 over 1.5 or 1.5. So you write that very fast. So that one was not very clear in our previous lesson, and I've done it again so that you can see what we are doing. Now, another question is 2 log to base 10 of 5 minus half log to base 10 of 16 plus 2 log to base 10 of 40. So 2 to base of that, so this is the same as log to base 10 of 5 squared, according to the third law of logarithm. And then this is log to base 10 of 16 power half. And this is log to base 10 of 40 power 2. Like that. So that is according to the third law of logarithm. Then we apply the first and the second law of logarithm, and this will be log to base 10 of, this is 25. If I subtract log 4, then it's like I'm dividing by 4. When I add by 40 power 2, it's like I'm multiplying with 1600. Then by 400, this will give me log to base 10 of 10,000. That is not the final answer. Log to the base of 10 of 10,000 is equal to log to the base of 10 of 10 power 4. And that means the answer will be, you can write it as 4 log to base 10 of 10. And what is log 10 to base 10? It's 1. So actually, this is 4 times 1, which is 4. But you can also, at this juncture, you can still say log 10,000 to base 10 is equals to 4. So you don't have to go through these steps. So what is important is just noting that log 10,000 to base 10 is 4 because 10 power 4 is 10,000. So you check on that. So we move to logarithmic equations. Logarithmic equations. Logarithmic equations. Example 1. Solve the following logarithmic equations. Solve the following logarithmic equations. Solve the following logarithmic equation. The first one is log 3x plus 4 minus log 3 minus x is equal to 1. So, which law of logarithm are we applying? We apply the second law of logarithm for subtraction, and when we subtract, it's like we are dividing the number. So this comes to log into bracket 3x plus 4 over 3 minus x. So we have applied the second law of logarithm. And 1 is the same as what? Log 10. 1 is the same as log 10. And then we drop the logs. So what you do, you don't cancel the log, but you just drop it. And then you say this is 3x plus 4 over 3 minus x is equal to 10. You can write it given as 10 over 1. And then what you do, you cross multiply. I have 3x plus 4 is equal to 10 into 3 minus x. And this is 30 minus 10x. You solve the equation. What happens when you cross the equal sign? When you cross the equal sign, the minus changes to plus, and plus changes to minus. So this one will be 10x plus 3x is equal to 30 minus 4. So when you cross the equal sign, the signs changes, and then this is 13x is equal to 26. So x is 2. X is 2. So another one. So that's the first part. So that's right. So Cedric, you can write this very fast. Cedric, as you get here. So Cedric, write this question very fast. Cedric, you have just gotten into class late. So fine. So the next one, part B. Two log to base 10 of x minus 3 log to base 10 of 2 plus log to base 10 of 32 is equal to 2. Is equal to 2. So in this case, properly, so it is equal to 2. So log to base 10 of x is, this one is log to base 10 of x squared minus log to base 10 of 8. Where am I getting the 8? 2 power 3 is 8. And then plus log to base 10 of 32 is equal to log to base 10 of what? 100. So we have now organized the question well. So this is x power 2, this is 2 power 3, which is 8. And then the right hand side is log 100 to base 10. Then what do? We use the law of logarithm. And we say this is log to base 10 of x squared over 8 multiplied by 32. Why? Because subtracting means we are dividing, and then addition means we are multiplying. And this gives me log to base 10 of 100. So this one will be log to base 10 of 4x squared equals to log to base 10 of 100. So that means 4x squared is 100. So x squared is 25. And what is x? X is 5. X is 5. I want to tell you something here. X is 5. In this question, x cannot be negative 5. X cannot be negative 5. Reason being, log of a negative number do not exist. So we don't have log of negative 5. Even though when you take negative 5 to negative 5, you get 25, yes, but the x, when I put here negative 5, the log of a negative number do not exist, and therefore negative 5 is ignored. So in this case, x is 5. X is 5 only. So I want to give you also another scenario, and then you check what happens. So I hope that is clear. So if you are given log to base 2 of x squared minus 9 is equal to 3 log to base 2 of 2 plus 1. So this is log to base 2 of x squared minus 9 is equal to log to base 2 of 8 plus log to base 2 of 2. Log to base 2 of 2 is 1. So this is log to base 2 of x squared minus 9 is equal to log to base 2 of 8 times 2 which is log to base 2 of 16. And at that juncture, you have x squared minus 9 is 16. So x squared will be 25, but in this case, x will be negative 5 or 5. So this question, the x is negative 5 or 5. Why is that the case? Because if you go back here, if I put negative 5 and I square it, it will be 25, then minus 9 is 16. So because of the way the expression is, then we accept both values. What happens when you write x is equals to 5? Then in exam situation, A0, you will not get the final mark. If you write one answer, A0, so you will not get the final mark. But in the other question also, if you write 5 or negative 5 in the previous question, you will still get answer 0 because you have to state clearly what is your answer. So check the difference between this question and the previous question because we have to get the total marks. Another one. Suppose you are given that. So this is log to base log of x plus 5 is equals to log of 4 over x plus 2. So remember, it's just application of the laws of logarithm. So this is 4 over. So that means that my x plus 5 is 4 over x plus 2. And then you cross multiply. So we have this equation to solve. So first of all, expand the left-hand side. So this is x into x plus 2 plus 5 into x plus 2 is equal to 4. So this is x squared plus 2x plus 5x, that is plus 7x, and then plus 10 is equals to 4. So this is x squared plus 7x plus 6 is equal to 0. X squared plus 7x plus 6 is equal to 0. Then we can use factor method. This will be x squared plus x plus 6x plus 6 is equals to 0. And this will be x into x plus 1 plus 6 into x plus 1 is equals to 0. So this is x plus 1, x plus 6 is equals to 0. So in this point, when x plus 1 is 0, x is negative 1. When x plus 6 is 0, x is negative 6. The one thing you need to understand here, if I leave my answer at this point, will I get full marks? The answer is no. Because if I look at negative 6 and I substitute it here, this will be log of negative 1. If I substitute negative 6 here, it will be log of negative 4. And you know, log of a negative number do not exist. But if I put negative 1 here, I'll be having log 4, and here I'll be having log 1. So the negative 1 satisfies the equation. So you say, ignore negative 6 since log of negative 1 and log of negative 4 do not exist. Therefore, x is equals to -1. So if it's an exam situation, the third mark is where x is -1. So when you leave your answer as -1 or -6, you will not get a full mark. So you have to discriminate and ask yourself, which am I going with the two answers, or is there an answer that I am supposed to ignore? So in this case, you will ignore -6. So, can you try the following? Try the following. Try that, and then you give me the answer. Just raise up your hand over there. So try this. Try this. What is the answer? What is the answer? What's the answer to that question? Answer? What is the answer? Welton, okay? Welton, are you through? Are you through, Welton? Are you through, Welton? Nyokabi?
Not yet.
Are you through? Are you through? Nyangor? Are you getting something? Are you through with this question?
Yes.
What is the answer?
X is equals to 1.
X is equals to 1, that's very good. So there's something also we need to take note. So NB. The first thing is that suppose log B to base A is equals to T. Suppose log B to base A is equals to T. Or let's talk of M. Then you know that A power M is equals to B. A power M is equals to B. So let us take logs. Taking logarithms on both sides, then log A power m is equals to log B. Log A power m is equals to log B. And you see in that case that m log A is equals to log B. So m will be log B over log A. So m will be log B over log A. So there is something now we have come to notice. Thus, log B to base A is log B over log A. Log B to base A is actually log B over log A. That is NB number 1. Then number 2, if I have something like log 8 to base 2, what is log 8 to base 2? Log 8 to base 2 is 3. And what is log 2 to base 8? You will realize it is a third. So log 8 to base 2 is 3, and log 2 to base 8 is a third. So when I interchange, then I get the reciprocal. So thus, log B to base A is the reciprocal of log A to base B. So that is the other formula you have to take note of. So let me give an example to satisfy maybe those two. Example, solve the following equation. Solve the following equation. Suppose I have log x to base 3 minus log to base x over 81 plus 3 is equal to 0. So how do you approach this? So this one can be rewritten as log to base 3 of x minus 4 log to base x of 3 plus 3 is equals to 0. Why have I done this? Because 3 power 4 is 81. 3 power 4 is 81. Then, if you look at it keenly, I have log x to base 3. I have log to base 3 of x. So it is advisable that the one that we have, like the log x to base 3, that is the one we let it to be a number. Like for example, we say that let log x to base 3 be 1. Then log to base x of 3 will be 1 over y. 1 over y. Then from there, you now write y minus 4 into 1 over y plus 3 is equals to 0. Then you multiply through by y, you get y squared plus 3y minus 4 is equal to 0. And then you solve. So this is y squared plus 4y minus 4 is equals to 0. So this is y into y plus 4 minus 1 into y plus 4. Be very keen there. This is plus and not minus, and that is equal to 0. So this is y plus 4 into y minus 1 is equals to 0. So this is y equals to -4 or 1. So this is what happens. You come back to the question and say log x to base 3 is -4 or 1. So what is x? So x will be 3 power -4 or 3 power 1. And what is 3 power -4? It is 1 over 3 power 4, which is 1 over 81. So it is 1 over 81 or 3. And that is the answer. Now, before as you write and before we look at the last question, I want to alert you that due to maybe an unavoidable circumstance, our lesson tomorrow will start at exactly 8 a.m. Are we together? So tell the rest, in fact, share, so that when you are moving to other classes, please inform your members that tomorrow's class will be at 8 a.m. 8 a.m. So take note of that time. So we will be having a lesson from 8 a.m. to 8:40 a.m. Thereafter, you are going to receive assignment. Those who I will meet next week, make sure you hand in your assignment on Monday. Those that are going to meet, you make sure you hand in your assignment on Monday. So I'm going to leave the assignment tomorrow. It's a paper, and then you print it, and then you do it, and then on Monday, I'll be able to mark. Some may even submit online, but I'll be able to mark. You'll come with it. So let me look at the final question. So suppose we are given, so find x if 5 power x plus 2 is equal to 7. 5 power x plus 2 is equal to 7. So in this case, you introduce logarithms and you say log of 5 power x plus 2 is equals to log of 7. So this is x plus 2 log 5 is equals to log 7. So this is x plus 2 is equals to log 7 over log 5. So let the calculator do that for you, which will get us 1.2091, and therefore the x will be 1.2091 minus 2, which is negative 0.7909. So you can get a similar question in KMF and should be able to answer that. Remember, this is not a form 2 question, it is a form 3 question. Now, so let's say we have we are told to evaluate log 32 to base 4. If I have a log 32 to base 4, I've said that that one is also the same as what? Log 32 over log 4. Log 32 over log 4. what is log 32? Log 32 is log 2 power 5. This is of log 2 power 2. And this is the same as 5 log 2 over 2 log 2. And this is 5 over 2, which is 2.5. And this is in agreement with what we had said earlier, that if you take 4 power 2.5, it will give you 32. 4 power 2.5 will give you 32. So this